finding our eigenvectors and eigenvalues can be used to what's called diagonalize a system or uncouple a linear system. And essentially what we're doing is we're finding out all of this information. We're finding out what x inverse is, what a is, what x is, and what this is capital lambda. Capital lambda. So it turns out that a matrix A, or a system, is diagonalizable if and only if it has n linearly independent eigenvectors. So if they are, and this occurs when we have distinct eigenvalues. So if we find our eigenvalues, we can have more than one eigenvalue show up twice. So if I have a 3x3 system, I might end up with like -1, and 2. Turns out we can only diagonalize a system if it has distinct eigenvalues. So -1, +1, and 2 would work, but not -1, -1, and 2. And then we just find each of these components. So we find our eigenvalues. That's our process. We find our eigenvectors. And then what we're going to do is use those to find our lambda matrix and our x matrix. And then we can find the inverse of x. We already have A. A is just our given matrix. Lambda is going to be our eigenvalues along the diagonal. And then and then x is going to be our eigenvectors as columns. So here's my first eigenvector. That corresponds to my first eigenvalue. My second eigenvector, that corresponds to my second eigenvalue. My third eigenvector, that corresponds to my third eigenvalue, etc. So we just put all of our eigenvectors in a matrix next to each other, put all of our eigenvalues in a matrix next to each other, find the inverse of x, so that we can write x inverse A times x equals lambda. And it turns out that this is true. So this is called decoupling a system of equations, uncoupling, diagonalizing a linear system. And there are different properties of these, reasons why we would want to do that. Some applications of doing this, some of you guys may have already seen using eigenvalues and eigenvectors to solve systems of differential equations. A lot of this stuff happens behind the scenes with a lot of different principles that show up in your junior and senior level classes. You can use eigenvalues and eigenvectors to study material deformation, dynamic systems, signal image processing, principal component analysis, which is a reduction of your essentially space that you're working in, numerical methods, control systems, pattern recognition. All of these fun things show up in your in all of these eigenvalues and eigenvectors show up in all these fun things. It also shows up in time travel, in Avengers Endgame, which is really awesome and fun. So there's lots of different applications for eigenvalues, eigenvectors, and diagonalization. And we'll go over many problems in class.